But you do want to know what your organic matter is. Nitrogen, typically they're not going to tell you, but if your lab does do a nitrate, and that can be useful. Phosphorus, I'm going to show you, that's one of the key ones we want to watch. And then these cations, potassium, calcium, magnesium, and sodium. And I've got recommendations in your handout, and we're going to look at that. We're also going to use this term electrical conductivity, which is a quick test that tells you the total amount of soluble salts. And we're going to use that a little bit here. Okay. So how is the tunnel different than their field? All right, number one, I've already kind of introduced this. There's no rain, right? And so no leaching potentially. There could be flooding if you didn't build your tunnel in the right spot, which we try to get everybody to do that right. The other key thing is that it's going to stay warmer in there. And so our tunnels on campus, I was in those Thursday, the ground is still not frozen, even with all this really cold weather. I was in Minnesota a couple weeks ago at their organic conference the first week of January. They're mostly not growing in their tunnels in the winter, particularly up in zone 3 and 4. They're saying, the ground freezes pretty solid. So we're talking about what can we do for your local food system when you do that. We have funding now, and we're going to be starting a student organic farm-like farm at the Chatham station up in the UP. So we're going to learn, just what does it take to grow, in tunnels up at that latitude and with that snow cover. But in general, it's warmer, so your microorganisms are staying awake all winter long. And what does that mean for your organic matter? They're degrading it, so that we're going to need to put more organic matter in a tunnel than in the field. In the field, organic matter degradation is stopped right now, right? Nothing's happening. But that's not the case in the tunnel. And we're also doing a lot of irrigation. I took out all the irrigation slides out of this talk just to focus on fertility. But how you water in the tunnel is really important. And, it's like talking with somebody who's here at the conference, and we co-presented at the Family Farms Conference 2 weeks ago on a beginning high tunnel where this is more advanced. And it's like one of the key things she said is, what are you doing? Well, you're keeping, it warmer and everything, but you're also preventing all the rain. And what does that mean? You got to get in there and water, all right? And somebody who's not used to, for those of you that have done tunnels, that's like, duh. But it's like, if you haven't done it, some people don't know just how much water you've got to put in there. If you're talking about an inch a week, if you're running a hose at 5 gallons per minute, that's like, I forget what that number is it's 2 or 3 hours a week. You need to be in there running that hose on a 30 by 96. I think it's actually more than that. So, or you got to put in a drip system, but you got to get that water in there because that's going to impact everything, but not so much water that you leach everything away. Here's a graph from quite a few years back, but looking at the soil temperature, how it gets cooler and cooler as we go through December. And we saw over a few years pretty consistently that right about the middle of January, it hits bottom, and then it starts picking back up. All right, so we're already getting close to here at the beginning of February. Things are, should be starting to warm up now. And I think that's consistent with what Elliot Coleman was saying. What happens when that soil really cools down? So some of you know about nitrogen availability, right? So we have organic matter, and we get it to break down, and it becomes available as ammonium, NH4. And then it gets converted by bacteria to NO3, and that's mostly what the plant takes. So all that is very temperature dependent. And what happens when the temperature drops below 60 here? Everything pretty much shuts down, all right? And what have we done where we did, if I showed you a graph like this of days to harvest for planting seeds like lettuce for growing baby salad mix, this goes down, and what does the days to harvest do? It goes like this, all right? Once the temperature drops below 60 in the soil, everything starts slowing down in the tunnel. And it's for a variety of reasons. There's less light, less photosynthesis, but also less nutrients. Okay, so let's jump into this comparison here. What's our soil type? About 40% sand, 33 silt, 25 clay, about 3.5 organic matter is where it started. All right, and so this is an intersection of a loam, a clay loam, and a sandy clay loam. I generally would say it's a heavier soil. All right, it's only 23% clay, but it's, particularly once you get down below 8 inches or so, our soils are pretty heavy. The number of hoop houses, we got 2, well, that's the heated one in 96, 2 in 2001, 1 in 2003, that's 20 by 96, 1 30 by 96, and then we added a 30 by 96 in 2006, 30 by 144 in 2008, 30 by 96 mobile in 2010, and then the worm house in 2012, and one on campus actually in 2012. Yeah, the worm house was in 2010. So we got a bunch of them. So we got a lot of data to draw on. All right, there started in the very beginning. In October, I had 240 2-foot by 2-foot plots that were all hand seeded in here, gathering data about the salad greens. And now it's all mostly in CSA production. And those early years, we had prepared the soil with dairy compost before the start, and so fertility level was all up plenty high. This house actually sat empty through the fall, and we planted in February. The growth was so scary here this spring. I mean, the bok choys were giant. This was our first month of distribution of the CSA, and it was crazy how fast stuff was growing. But the nutrients, nothing had been growing in there over the winter, and the nutrients, the nitrogen, I know was pretty good. And but by a few years later, I'm going to show you how we lost a lot of that, and production was going down, and what we did to fix that. Here's in 06. So this was a field that was used for field production, and then the hoop house popped up. This is a nice big hoop house inside where we started raising things up and putting our rows a different way. And then in 2008, this one popped up for growing salad greens for the university. And again, nice big growing area. So we've had a lot of chance to try a lot of different things. What's going on with our soil organic matter? So looking again, I'm going to show you a series of graphs from 01 to 2012. All right, so in the beginning, we started fairly low. We were doing some experiments with either compost or alfalfa meal. And we were getting the same yield out of both, but the one with alfalfa meal, that ground was really hard to work. Right? The other, it was getting like a half a gallon of alfalfa meal to a particular area. Actually, it was the not just alfalfa meal, it was the alfalfa fertilizer. I got a picture of it coming up, the Bradfield alfalfa fertilizer. So it had some potassium and some other things in it. The other zone of equal size was getting 6 wheelbarrow loads of compost. Okay, so similar yields, but much different soil property. Eventually, we came in and we zapped these houses with a lot of organic matter here. And then what we've been doing differently is instead of just amending the beds once a year with a 5-gallon bucket of compost, every time we plant a new crop, we put in 5 gallons, so they get 2 to 3 5-gallon buckets per 20 square feet. All right? And I got to come back and I'll tell you what kind of compost, but it has no manure in it. Okay, it's a plant-based compost, and we have 2 different ones. One that we make, I'll show you, from hay and straw, and then one that we buy that is very old leaf mold, okay, that we get from Titus Farms. So we've been able to keep this organic matter up pretty consistently now, but in here we were having a little bit of trouble. So here's like in 05, this house was that same one I just showed you. And it was summertime, the ground was getting harder to work even with the broad fork. So we came into the houses and we had a mixture of leaves and previously composted wood shavings that were well aged, and we just dumped quite a bit in, and then we would rake it out, and then we went over it with a tiller. This house, most of these houses, we took the ends off so that we could drive the tractor through and get it in there. Here's back to that house I showed you originally. We worked all that in. We watered it really well to get the ground going. We reformed our beds in August and planted, and man, that fall things looked great again. Okay, so it was building that up. That wasn't a lot of nitrogen from dairy compost this time. This was just a lot of really good leaf mold and other materials, and continuing to do what we learned to do about balancing. I'm going to show you the calcium and stuff, but we're learning based on everything that I knew from my 12 plus years of experience growing in the greenhouses, that our water here in Michigan, if it comes from a limestone aquifer, it makes the pH go up. Every time you water, it's like adding lime. And most of Michigan is like that. If you're from the Detroit area and you're getting city water, out of the river or something, greenhouse growers there use different fertilizers than greenhouse growers in Grand Rapids, for example, because of the water difference. So our pH was going up and up and up, which you're going to see, I think, maybe the next slide. And we started doing something to adjust it back down. And that was part of this process, too, of seeing this better green color, the things that we were looking for, and hopefully making really good nutrient-rich food. All right? So what comes into keeping your soil healthy? Good sanitation, so that you don't allow diseases to develop. Good rotations. I do another whole talk where we tell about our rotation at the farm. Where we've got early season and late season and warm season and cool season, all the different stuff that we plant and rotate 50 different crops. But for today, we're not going to get in there. But we are going to talk a little bit about these organic matter fractions. The fact that it's not just about adding organic matter, it's about making sure that you have a blend of the right types of organic matter. So you want to have plants growing in there that are feeding the bacteria and making really readily available nutrient or carbon. So that's kind of like the leaky roots thing I told in the other thing. Our plants' roots are leaking out sugars, and that's for a reason. It's to feed the biology in there, to keep it going, which helps keep nutrients going. Then there's the dead part of it, which is stuff that is a few months to a few years old that's slowly breaking down, right? And as they break down, they're going to release nutrients. And that's the cycle, the soil food web, and that's how organic farming works. I wasn't planning on saying that here, but it's like the best way I know in class to explain organic farming is to share the story that I learned from the farmers, is that you've got, let's say in the soil, you've got a lot of bacteria, right? And they're the bottom of the food chain. They're really simple, single cell. If you look at how many carbon atoms they have compared to nitrogen, it's like 5 to 1. They don't have, and other stuff that we have, bones. If you look at our carbon atoms for every nitrogen that we have, we would have about 30 to 1, right? Because we have a lot more structure. So you have these really simple bacteria, and they start eating the plant material, right? But what's the next thing up in the food chain that's going to eat the bacteria? Let's say a nematode, all right, which is a little worm that you can't really see, and it has a body, though, more structure. It has about 15 carbons for every 1 nitrogen. So it's about halfway between bacteria and larger organisms. So let's say this nematode needs 15 carbons. So how many bacteria does it have to eat to get 15 carbons? If there are 5 carbons per bacteria, let's say. 3, right? So it eats the 3, it gets 15 carbons. How many nitrogens does it get? 3. How many does it need, the nematode? 1, right? What happens to the other 2? They get excreted out, okay? And that's organic farming in a nutshell, right? It's like you're encouraging all this soil food web so that as each thing eats something else, the extra nitrogen is getting excreted into the soil and it becomes available for the plant to grow. That's how we farmed all the way up until about 1900. Okay, so it's only been the last 100 years that we've been taking nitrogen from the atmosphere and putting it into the soil. All right, but it's getting that cycle working, and that means you also got to have this really dead, but you also got to have the really, really dead stuff, and that's the humus or the glue that holds stuff together. So we're looking to build this. If I want to add like more mulch or stuff, and I put that onto my soil, how long does it take it to get from that mulch or a green manure or crop residue to get to humus? Typically it takes decades, okay? It takes, well, it can happen in years, but to build up, it takes a long time, right? How could we get humus, nice, mature material in a short period of time? Those of you that were in the last session, don't say. What's the tool that we use on the farm to make humus quickly? Compost, right? We get it really hot and we get all those organisms working, get faster, and we get really good, stable organic matter. And so it's the combination of those things that we're doing. How do you get nitrogen out of that organic matter? So in the last one I went through and we talked about if you have 1% soil organic matter, that would be about 20,000 pounds, because we say an acre of soil is about 2 million pounds. So if we say that 10% of that nitrogen, well, that 20,000 pounds would be about 1% nitrogen, and about 10% of that nitrogen might become available in 1 year, which means from that 20,000 pounds, you could get about 20 pounds of nitrogen per acre. How many pounds of nitrogen does it take to grow a crop of lettuce per acre? About 80 to 100 or so. Okay, corn might be 200 or 300. So how do we get that? Well, if we had 5% organic matter and it was breaking down like that, we could potentially get as much as 100 pounds of nitrogen available over the season, right? And that's what we're doing by building this organic matter. We're getting it up so that that nitrogen becomes available, and there's a whole other stuff of the course about learning how to get it available at the right time, and it's very dependent on soil temperature. But in the hoop house, it's a lot easier because it's not washing away and it's warm, and we can get it to be available. So that's what we're doing. If we need to, we can apply more nitrogen from other sources and get that cycle working also. So with that as background, here we go. Look at this pH. What's it doing? Up, 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 up. All right, and that's partly from the compost, majority though, because every time we water, we're adding lime. All right, so here's where we started adding some sulfur, and we're adding approximately, if I put it on a cup terms, like a cup per 20 square foot bed, which isn't much bigger than this table right here. That's a pretty lot of sulfur, and we're doing that once a year, okay? And that's helping keep the pH down in the low 7s or so, all right, which is where we're after. And I said where I haven't done that at home, I'm up here more approaching 8. So I think we're being pretty successful there, and you need to just watch your pH and know if that's going to happen. And this is, the high alkalinity, lots of calcium, lots of magnesium. This sulfur isn't in a form that's doing anything to the pH. So, you need to ask this question, what's in your water instead of what's in your wallet? How many of you had an irrigation water test done from a lab that does, the minerals in it? Okay, so I'm only seeing like 1 or 2 or 3 hands or so. So that's a thing on your to-do list, is maybe have your irrigation water checked. What's happening to our soils over time? Look at our cation exchange capacity. That's increasing. Why is that? That's because our minerals are increasing. That's how cation exchange capacity is calculated. They look at how much potassium you have, how much calcium you have, and how much magnesium, and they kind of add it up, and they come up with this number. And so this is good. This is a good thing, and it means that our buffer, our reserve, is better. So I don't worry too much when we're planting crops in there, as much as I did back here, because we have a pretty good buffer built up over time. And I don't worry too much that it's all going to wash away because we have a cover over the top of it. Soil phosphorus jumped up really high when we put on that dairy manure from the very beginning, and it's stayed up. We have not really had to add any phosphorus in our tunnels over the years, okay, over 10 years. I'm not sure why this dropped down. We'll see with it whether it comes back up. Sometimes you just get an odd soil sample, and I'm not sure what was going on there. But still, this green line is what is generally recommended, so we've got plenty. Is that translating to more in the food? I do not know. I would like to know, and we get enough money to do the research, we'll be able to work on that. But here's potassium. This is my concern, is that we started out with that dairy manure, a nice load of potassium, but we came down. So what's happening in here? We have started using potassium sulfate, which is allowed in organic farming to keep that up. I don't have the rate of that off the top of my head, but that would be, a common thing that you can do in an organic system to keep bringing that up. Sometimes green sand is recommended. I don't think green sand is that soluble to get us to the levels that we need. So this is what we're doing.
Do you know what your calcium levels were to get phosphorus into your plant? Would that correspond why it was gone? Because your calcium jumped up and your plant was able to uptake that phosphorus?
Probably not at the system that we have at the pHs where we're at. But what he's asking is a good question about the relationship between elements that can influence the availability of and the uptake of some. We're hearing a lot of good information about bringing calcium up, particularly what form and what ratio and how that can benefit. One of the things that's out there that I haven't seen the numbers yet, but I think farmers have numbers, is that by bringing up the calcium level, you can get more of the phosphorus that's in the soil into the plant. Right? And it's one thing to have it in the soil, another thing to get it in the plant, which comes back to that pH thing. Remember?
Plant sample.
Right. You can sample your plant and find out. But even the pH thing that I mentioned, it's like I know that I can have lots of iron in my soil. But if it's all tied up at a high pH or at a very low pH, it can also get tied up. It won't dissolve. It'll be in such a form that it can't get across the root. And so that's why I try to get my pH right so that the iron atoms can get across the root. And the same thing with calcium is getting it across. So we're continuing to build up calcium, which would fit both because we're our water and because we're adding gypsum every year. Our soils are probably pretty saturated now and are at near the upper level of what you would call calcium availability. And partly because of this magnesium also continued to increase over time, and it's this ratio between calcium and magnesium is of concern. So I'm glad right now this doesn't seem to be going up much higher, which I think is partly because we're continuing to add the calcium. We just have to keep watching this. But we don't need, this is all we need. But we can't get rid of that. People ask, what if you do have too many salts in your high tunnel? Should you just go in there and water the heck out of it and push it down? I would say no. I would think that would be a really bad idea because I know from greenhouse work that it takes lots and lots of water to push it down. It's not practical. What I would do is let it rise up to the top, and I would scrape off a little layer of that and take it out and put it on a field somewhere or put it on a compost pile if you really could show that you had a problem with salt accumulation in your tunnel, which I don't know of anybody yet who has demonstrated that. I was involved in discussions 8 years ago where people were seeing the crust forming on the top, and what are we going to do about that? No one has yet shown that there's any problem there. Okay, but analysis would tell you if you had a problem. So here's your potassium. Again, looking at what percent of the salts are potassium. This is where we're at this critical, so we need to bring that back up. Calcium, we're nice and high up here where farmers want to be in the 70%. Magnesium, we're over where people would want to be, but we can't do much about that. So we're just watching to see what happens. We're doing good so far. It makes sense.